Hello, everyone. Glenn Sullivan, Senior Director of Products here at Infoblox. I manage the strategy and roadmap for Universal DDI, Asset Insights, and our as a service offering. So basically, if it's SaaS and it's DDI, it's on my product management team. I'm here today to talk to you about Universal DDI, which is smack dab in the middle of this product suite here. You can see they're highlighting Universal DNS Management, Universal DHCP Management, and Universal IP Address Management, or otherwise Universal IPAM. As we like to shorten it, because everything we do is an acronym inside of an acronym, right? So we're solving customer challenges, right? And if you were attending the earlier session, or if you were watching the previous stream here, Mukesh touched on some of the multi-cloud issues that our customers see. So we're really focused on solving these challenges from a multi-cloud perspective, right? And you might be thinking like, oh, well, I'm not multi-cloud, right? Maybe I'm a hybrid, right? On-prem and some cloud, or maybe I have a lot of accounts in any one cloud, right? We look at it all as a similar set of challenges, right? If I have, deployments in AWS, and I've got deployments in Azure, and I've got deployments in GCP, or maybe I've got 300 accounts in AWS, that certainly looks a multi-cloud, even if it's only technically in one cloud. The things that we see from a customer challenge perspective is we see that workflows don't apply across the board, right? On-prem workflows don't apply to cloud. Cloud workflows between the clouds don't apply as well. We also see that there's different tools and vendors that are used in each one. There's a different API to maintain, right? One of the things that we like to touch on is human error causing trouble, right? Human error is the number one cause of outages, right? When I'm trying to keep things consistent. So of course you move to automation, and automation means that you get rid of all human error, except when we talk to our customers, we find out there's usually only, one or two people, maybe three if you're super lucky, that understand the 50, 60 lines of Python that really do pull, the next available IPs out of, the different environments, or set up the DNS records in Google Cloud DNS, right? There's really a lot of complexity hidden under the covers in any of these API implementations. Also, there's just a lot of complexity to managing different environments, right? It's different teams. You may have a cloud team that has AWS engineers and Azure engineers on them. You might have separate teams that might be completely siloed, either on purpose or organically, right? You may have different tools that you're using, right? The network team is very used to logging into Infoblox to manage DNS, but maybe they're not used to logging in and managing Route 53. So there's different tools that they have to manage as well. Also, every single different environment usually has a different service deployment model, right? What am I doing for DNS inside of a GCP environment? What am I doing for DNS on-prem? What am I doing for DNS inside of an AWS environment? They're almost never the same. And you could make them the same and backhaul everything, but then of course you've got, latency introduced and other problems that are caused by that as well, right? So deployments are varying across the board. So what happens, right, with these issues, right? Errors happen from manual configurations, services, outages, and delays, right? We see this all the time, right? We hear it every time we talk to a customer. They're like, oh, yes, there was a conflicting IP that was given out and it took out a major part of my environment. Or there was delay in deployment because there was a lot of back and forth about who owns a particular, part of the DNS solution, right? Also in decommissioning, we see a lot of issues too, right? Like someone will do a deployment and they'll say, oh, we need to decommission that part of it. And they'll say, okay, well, who created that record? And there's no record of who created the record. So then everyone's afraid to delete it. So there's a lot of, complexity that gets introduced in the system as things go on and on. And of course, this introduces operational costs, right? It slows down your deployment. The more people that you need to manage your environments, the longer it takes for you to do anything, the more operational cost you have. So Universal DDI is the answer to these, right? So this is a before and after kind of slide, right? This is a current and after, and then you see like in the current, I've got two silos there, right? I've got the network team on the left and the cloud team on the right. And that red arrow between them represents kind of manual communications, right? Emails, phone calls, Teams, Slack, whatever your poison is for transferring knowledge between individuals who are trying to do an operational task. That's what is represented with that red arrow, right? And if you see the poor network admin on the left here, they have to manage, our portal, which, isn't hard to manage, but it's a tool they have to manage. Also, if they're using our on-prem tool, NIOS, right, our appliance-based deployments, they have to log in and manage that. Maybe they're managing our Microsoft environment from that as well, right? So they're managing a Microsoft environment, proxying it through NIOS, so that's another environment that they have to manage. Maybe they have direct access to those Microsoft servers. Maybe they're going through a server team to manage those. And then if they're doing external DNS, right, for their authoritative, in other words, they're hosting their, whatever.com externally, they're probably doing that through some combination of external services, right? They might be doing it with Cloudflare. They might be doing it with Akamai. They might be doing it with Vicara. There's so many, right, that they could be using, right? So this is another place whenever they need to make a change. So let's just think on DNS, right? We won't even make this complicated and talk about DHCP and IPAM. If I have to synchronize a DNS zone between all of these environments, I need to log in to 4, 5, 6, 7 different environments to manage those records. Creates a lot of places where error can happen. The other thing is then we have the cloud team on the right, and we have this represented as a single circle, right, with a picture inside of it as a single individual. But this could be anything. This could be a cloud center of excellence. This could be a team with AWS and Azure engineers on it. This could be individual teams that don't even talk to each other, and they all have different languages, right? So I love this example. I was on with a customer, and I had an AWS DNS engineer on the phone. And I had an Azure DNS engineer on the phone, like hyper specific. Their job was DNS in Azure and DNS in AWS. And I said, hey, we can manage the cloud forwarders. We can do conditional forwarding, star whatever.com. We can say forward that to this resolver, kind of a nerdy DNS thing. And the Azure person said, oh, well, you're talking about inbound and outbound endpoints. So I don't have that in Azure, so I guess you can't help me. And I had to say, hey, time out. It's okay. We handle private resolvers. And he's like, oh, I know what private resolvers are. That's Azure speak, right? The language of DNS between AWS and Azure is so different that the two individuals that worked at the same company couldn't have a conversation about DNS in Azure versus AWS. And I had to help bridge the gap between them to explain to them, no, these features are exactly the same. I have a decoder ring that I have hung up in my cube area, that tells me what each of these different clouds offer from each of their individuals. And we all know this, right? This isn't a DNS thing. It's AKS and EKS. Like every single cloud service has their different names for everything. So on the right is a different view of the world, where our portal is the center, the universal portal here, where you log in, and it doesn't matter if you're a network engineer or a CloudOps engineer. It doesn't matter if you're managing, one cloud or multiple accounts, multiple Entra ID tenants, right? In Azure, you log into our portal and you can see the DNS, DHCP, IPAM infrastructure across the board, right? DHCP more of an on-prem thing, right, than a cloud thing, but you will see that infrastructure across the board. And it's really important. You can see we made it very, very small and hard to see, but it's very, very dotted line there. It's a gray dotted line around the CloudOps team, and it points an arrow to the public cloud. The important part is that swim lane of the cloud team managing using the native tools doesn't go away, right? So if I'm an Azure engineer and I'm very used to the way that Azure manages DNS, and I want to log in and manage DNS that way, that swim lane is not removed. That still exists. If I want to, log in as a network engineer into our portal as opposed to logging into AWS, Azure, or GCP, I now can see those same DNS records, that same IPAM that I would have seen in the native portal in our portal, right? Keeping a nice view that is specific to what that network admin cares about seeing. The other thing you're going to notice is that green line between our portal and the clouds. That is cloud-to-cloud APIs. There are other implementations out there that have, gone down the path of managing DNS or managing IPAM in, some of the major clouds, but usually they revolve needing some kind of server deployment. Deploy an appliance, deploy something in the environment, interface with that, and then synchronize the data back to our portal. We've eliminated all need for deploying a server. We do cloud-to-cloud APIs for pulling all the information, both two-way sync between our portal and the three major clouds. The other thing you'll notice is on the bottom left there is our NIOS X physical and virtual servers. You'll notice the NIOS servers, the NIOS grid is now controllable from our portal. This was a door that was closed, previously a few years ago. When Mukesh was talking earlier about, hey, we're having two interfaces, we've eliminated that for 80+% of use cases. And we actually have a way of going into the exact UI of NIOS if there's some feature or setting that you want to set that's kind of we call those hidden nerd knobs. In a product that's been around a long time, we've added a lot of nerd knobs over the years. Those are all accessible via a nice view of the UI, which adds a wrapper to entering into that portal.
First, I just want to say thank you for spelling it's on premises. As the fellow that owns itsonpremises.com, I can proudly say you nailed that right. I even own itsonpremise.com, which forwards to itsonpremises.com to remind you. But what do we do for like L4 to L7 application load balancers? Because modern apps have different ways in which they allocate DNS. It's not layer 3 anymore. So what do you have around dealing with stuff where you get like a Cilium on top of Kubernetes, where it could be very dynamic? And like, what are the polling rates at which you push and pull to keep that stuff up to date, where we have apps that can come up and go away a lot faster than they used to in traditional DNS?
Great question. So we have a thing called DNS traffic control, DTC. It is our global server load balancing. It's based on DNS. So we have that for both NIOS on-prem or appliance-based, and we also have it for NIOS X. What it basically is it sets up DNS records with health checks and rules and round robin, other kind of load balancing type methods to say, oh, for this particular record, hit this server in these conditions. Essentially, it is something that is offered now. We are looking at how do we handle the more complex routing solutions. So I have some roadmap on that from like Route 53. So if you look at the three clouds, Azure and GCP have reasonably okay routing, from a DNS perspective. AWS has a lot of routing from a DNS perspective. So that's what my gold standard is integrate with that. And that's something that we're doing quarter over quarter. We're adding more different routing policies that we support. You asked a question. You asked a second question.
Yeah, specifically stuff like Cilium or Istio, because first of all, if you can find anybody that's successfully running Istio at scale, I want to meet them and kiss them on the ear because no one's done it. But Cilium, where they have all their network policies that are also security policies,
right?
So it's kind of a dual purpose there. But then,
if they write the record to Route 53, we'll pick it up.
Right. Okay.
There are some scenarios we found where things are like AWS has some of their own features that manipulate DNS without necessarily interfacing with Route 53. So what we do as a vendor who cares a lot about DNS is we urge those who are doing what I'll call fancy things with DNS to write them as a standard to one of the platforms, whether it's Route 53 or something else. Even if it's a synthetic record, right? If you write it to Route 53, we can ingest it and we can interface with it. Oh, the other question you asked was about polling intervals. We have a default of 5 minutes, but you can still do zone transfer for anything that supports zone transfer. And that's obviously instantaneous because it's the DNS, core protocol thing. Yeah. Unfortunately, a lot of the cloud vendors don't support zone transfer, but that's what we're for. So when people get into a situation where they're like, I want to do a zone transfer between these two vendors that can't do it, that's when we come in because we speak zone transfer and we speak API. We do that translation between the two.
I wanted to add one thing. So in Kubernetes environments, a lot of customers are using core DNS.
Yes.
As the DNS, which provides local fast DNS. And they're asking us if we could manage core DNS from our universal DNS. So that is something that is on the roadmap. Once we do that, then we would be able to serve DNS within the Kubernetes cluster using core DNS, but we'll manage it just like we'll manage Microsoft. The other thing you brought up, I've talked to customers that have used the APIs. So as these STO meshes come up, they would call our APIs and register the DNS records. And yes, they can happen fast, but they're bombarding our APIs and saying it's not scaling and we need to make it faster. So that's That's what they're doing. Right?
Yeah, and the reality is mostly 5 minutes is plenty fine, but we're nerds and we love nanoseconds and microseconds. As they always say, if you're writing JavaScript apps and you're worried about microseconds, stop writing JavaScript apps. Like it's too bloody bad.
And in Kubernetes, there are two types of pods. These server types pods, they don't go away, and they come up, register themselves to Istio or whatever service mesh, and then they're there. They're serving applications. So those are not the ones that go away in seconds. It's the jobs, the task types, but nobody needs to connect to them. They're connecting out to something else, like they do some calculation, download some data, post some results. So nobody is really connecting inbound to those. So they can go away, and there's no problem with them.
And of course, you mentioned Core DNS specifically. What about console? If you're going to pick another one, my hacky core friend over here. If you want a great course on console, go to.
Fair enough. Yeah, Core DNS is actually a part of our threat defense product line. So we actually use Core DNS as the DNS forwarding proxy for proxying DNS traffic on-prem and sending it to our cloud for cloud resolution. So we've got a long history with Core DNS. Doesn't mean we won't look at others, but we have a long history with Core DNS. You'll also notice there's two other things on here I want to touch on before we move on. On-premises, as we said earlier, for Microsoft is something that is in development now. We're actually going the agent approach. The agent would run on a Windows device that's not necessarily the domain controller, because it's the fastest way to get the data that we want to be up to date and current with the DNS changes and everything that's in there. The other thing that we've learned is that Microsoft admins are very used to working with agents. They're not so used to working with an appliance that sits somewhere in their network and does a bunch of API calls into their Active Directory domain. So it's something that we're actively working on. And then third-party cloud DNS is also in the works right now for Cloudflare Akamai. But I'm not, pedantic about any particular one. I want to support any one that our customers are using. So whatever the DNS, external, service of choice is, that's what we're aiming to support, because we recognize that obviously with cloud scale applications, these companies have made a lot of investment into having external DNS that's available as a CDN level. So the goal is to support whatever they're doing, as opposed to saying, oh, the external DNS query has to come through us. That's not in the spirit of universal DNS.
I've got a quick question.
Sure.
What I'm seeing here is like that traditional single pane of glass, like management plane for, like you're describing, all the API calls going to all these different systems. Is it safe to assume that your inbound API for the portal abstracts that layer of complexity as well?
Yes.
And if I need, okay.
Yeah, I'm glad you asked that, because it's actually a major point of pride, is because we recognize that there's a lot of differences between the APIs that are, for even creating a single record between the three clouds, right? So we abstract that away and say, okay, create the zone that's managed by us, that's synchronized with AWS, Azure, and GCP, and then that's a single unified API for you to learn. Yes.
Yeah, interesting. So is there like I don't want to go too far, but is there like a flag or a parameter that you pass that says create this there? Like, for example, in Azure, or do I not care? I'm curious on.
Yeah, so we have a concept, it's borrowed from Bind, called views, and these zones live in a view, and that view is dictated by provider.
Right.
I am looking at how to do what we call viewless zones that would synchronize with multiple zones simultaneously. It's something that's in the works. But right now, you know where you're writing it to, because the view dictates where the zone lives.
So the API key would be per view that I'm going to, okay.
Yeah.
That makes sense.
Yep.
Now the API key to the portal is the same, and the calls you will be making to the portal would be the same. It's just a field that says this zone goes into this view.
It's a URI.
Yeah.
It's part of the URI.
Okay. So it's part of the payload.
Because
okay, gotcha.
One of the values we are providing to customers is they don't have to maintain 4 different API keys and API credentials. They can just maintain one with Infoblox, and one API credentials, one key, one Terraform provider, and we translate everything behind the scenes for them.
Yeah, that makes a lot of sense. Which is why I'm asking that question. Like I see the complexity removed in one area, but potentially complexity added somewhere else. And it sounds like you've solved that, but we'll see.
Correct.
Okay, just wanted to touch on a couple of use cases before we hand it over to Jason to run the demo to show you guys how all this works. I wanted to talk about a couple of use cases that are specific that we've seen our early customers use and through our early access program. One is a large SaaS provider, global. Everybody would know the name if I said it, but I can't say it. They had some impacts from CrowdStrike outages with having all of their DNS and DHCP running on domain controllers, right? So, and you'd say, well, they're a large SaaS. They shouldn't be doing that. Well, everybody has very large networks, and those large networks are segmented, and they're all different, run by different teams, right? The cloud application team doesn't necessarily manage the corporate network that users log into when they walk into a building, right? So they were moving off of Microsoft, and they recognized that they needed to get DNS and DHCP off of that and have us run that on-prem for them, but be SaaS managed and SaaS controlled, because clearly they're a SaaS provider, they speak SaaS. Therefore, they didn't want to just run another appliance that needed to be logged in individually. Another one is a healthcare system where local survivability was key. Local survivability is the concept of obviously being able to serve DNS and DHCP protocol, whether or not I can get to the internet, whether or not I can phone home, whether or not I can phone home to my data centers. So everything that we do from an NIOS X point of view is for local survivability, so that it gets its configuration, it gets its updates from the cloud, but any kind of interruption, it keeps serving DNS and DHCP protocol, right? And this health system had a tornado that took out a hospital. They had no WAN, they had no internet for weeks on end. So those are the use cases that we designed for. We have cruise ships that literally go out to sea. They can't phone home for weeks. They can still serve DNS and DHCP. The last one I just want to touch on is a e-commerce, luxury e-commerce brand that uses us for IPAM for public cloud, right? So they've got a lot of AWS implementation. They're pulling, new allocations constantly for VPCs that they're standing up and tearing down. They're using Terraform as a way of getting the data out of our system because we're authoritative for IPAM. So they're feeding, metadata that says, I need a /24 in AWS US East 1 in the PCI, environment that matches, staging or dev or whatever. They give us those parameters. They ask for the next available subnet. We give them that next available subnet, and they use Terraform as a way of interfacing with the VPC create in AWS and the way to write to us authoritatively. Do they have to do that? No, there are other ways they can do that, but they've standardized on Terraform. So any kind of automation that someone's bringing to the table, we're looking to integrate with, as opposed to dictating that we have to be the automation platform.
When you do something for the local survivability, does it become like a independent multi-master, and then when they reconnect, they reconcile? Or do you only go to read-only mode? Like
it's only read-only mode. It's meant for being kind of a satellite until it's reconnected. So there's no reconciliation that needs to happen because there's no config changes that are made.
Is there any opportunity to actually still inject new records in an off, like in an?
There is a request to do that, and we are working out the right way to do that. My point of view on it is there would be certain record types that would be synthetic, that would be injected during a DR situation. So we're looking at how to do that right now, but that's because people don't want to change everything, because that would be kind of a reconciliation nightmare. But most people say, hey, I've got this 20, 30 CNAMEs that need to get updated in a DR situation. So that's what we're looking to provide.
Yeah, that's the primary use case I used to have, was like literally you would take one Active Directory domain controller and we'd slice it off for an active disaster recovery exercise. We treat it now as the master, but then when we're done, we shoot it in the temple, and then we never bring it.
That's the use cases that we're building around the most.
Mm-hmm. So, as product management, how much of your time is spent? So, because obviously internal structures are different for each place. The way they have cloud teams, they have DevOps teams, they have sysadmins. So, how much are you spending your time on tailoring it to each one of these, and then having to navigate within it to sell to these people? And to what extent, if you do you change the product? So I don't know if you know, for example, for these use cases, how each one, their IT groups are set up. Does that make sense?
So I spend a lot of my time talking to both network operations teams and CloudOps teams. And the best calls I have is when they're on the same call, but sometimes that doesn't happen. We do tailor features just for CloudOps. The nice thing about coming from the NIOS point of view, with the number of customers we have that are doing DNS, DHCP, and IPAM, primarily on-prem, is we have that user base nailed. We know everything about all of their problems because we've been building products for them for years. The CloudOps teams were coming at more from a, hey, what are the interactions you're having from the NetOps teams? What challenges are you trying to solve? When you get an allocation from them, how do you use it? You know, giving the network team the visibility and how those allocations are used. These are the types of conversations that we have with CloudOps teams. And they have a whole host of IPAM issues that some of the folks on the network team solved years ago. The more CloudOps teams I talk to, they're solving these problems with spreadsheets, which is exactly the same problem that network teams had 15 years ago, 20 years ago, you know, doing IPAM on-prem.
So would you find that pretty consistently? You have CloudOps, NetOps. You don't have integrated product teams, or is it, each place has their own sort of tweak on how they have their.
Yeah, so we do find that some customers have like a center of excellence, but it's definitely not as common as having a separate team. The one place where things get interesting is DNS, because if there's one place where the network team manages something that's in the cloud for the CloudOps teams, and the CloudOps teams really aren't, you know, keyed in on how it's working under the covers, it's DNS. That's the number one place where I see a network team having like a cloud person who knows how to speak cloud and knows how to speak network, and that's for managing DNS in the public cloud.
Thanks.
Okay. Hi, everyone. I'm Jason Radebaugh, a manager with our technical marketing team. So I'm going to show you a couple quick demos right now on universal DDI. So we'll start, Glenn was talking about the DNS management piece, and so that's what I want to start with, is kind of that most basic. Yeah.
Can you zoom that in just a little bit? Some of us have old eyes.
Sure.
Thank you for saying that and saving me this question.
I'll follow my sword. That is great.
Okay. All right. Good. So, so I'm here on our DNS zones page. Like Glenn said, we work with this concept of DNS views right out of Bind, where we can separate different providers, or we could, you know, separate DNS zones based on where we want to serve them for clients or endpoints, et cetera. But what I've done is I've connected up our public clouds with UDDI in my system. So for example, I've connected it into Google Cloud, right? And we can see here, I've synced all these zones across from Google Cloud. If I go over to my Google Cloud console here, I'm going to see I have the same zones, and I can dig into any of these zones and look. Like, for example, here's my my records in this gcp.mycorp.com zone. Back in the Infoblox portal, we can see that we're also syncing all of the records in as well, right? But we're not just syncing it. It's not just that one way. We're offering that ability to manage it out of our Infoblox portal and UDDI. There we go. I'm just going to make a quick change to that DNS record, updating our IP address. If I go back over to the Google Cloud, we'll see almost instantaneously, right? We've pushed that change. Now, being able to do that for one cloud, right? It's okay, but it's a fairly simple thing. The value is in bringing all of those different systems under that same management. So, for example, I want to do the same thing in AWS. I can go to my AWS view here, and once this loads, we'll get all my zones from AWS on the console side over there. Let's just get to Route 53 real quick. Take a look at our zones in AWS. And again, here's the zone we're going to look at. We can see records on the AWS side as well as on the Infoblox side. And we're not just limited to working with those existing records, right? I can create a new A record here and push it out to this zone. So we'll just give it a simple IP and whatnot here. I'm going to set a TTL, and we'll save and close and push this new record to AWS. All right. So jumping over to the AWS portal.
Real quick, is it doing a validation before like you can actually submit it? So is it looking at that you have an existing IP address or anything right there, or you just blindly being able to-
So I have the freedom to shoot myself in the foot, basically, right? I can enter in any IP address I want there. However, when we get into the asset insight side, which is going to be kind of our next topic after this, I am going to show you how our system will recognize when maybe I have some records with invalid addresses and things like that, and we are doing some detection around that.
So you can introduce human error right now at this point. Then there is validation.
Sure. Yes. But I'm going to help us catch it, right, with another part of that same system. But it's not always an error, right? There may be cases where using that outside address that's not in my system yet, I do need it. Maybe I'm creating a record that's pointing to something in a partner's organization or something like that, or something that's outside of my basic control. So there are use cases where I want that freedom to enter in any and every address that I might need to be able to use for DNS.
You're creating an A record here. What other record types are supported from Portal? Does it have full support for all the different weird AWS things?
No. So right now we're just working with the basic record types. So A records, C names, MX, all your basic record types. And then, as Glenn said, we are looking at expanding that integration to say some of the funky AWS routing records and all the different type of stuff you can do there. So definitely, looking to integrate that more in the future. For now, you can kind of see it's mostly pretty basic record types.
Yeah.
But if I create it on the AWS side, will I be able to see it?
You're gonna see it, but you're not gonna see it in the same form, right? So, for example, if I create some routing records on the AWS side, I might see multiple A records on my side here, since we're not fully working with those routed records yet.
And how do you work with like the alias CNAMEs inside AWS where they're presenting their dynamic backend?
Absolutely, and that's a great thing to be able to do. Yeah, where you're using, say, the alias records and it's pointing directly to a service. So because we know that IP or whatnot could be dynamic, we can sync that and work with that just fine.
And for TXT records, just because when you get singles, they don't have quotes. When you get multiples, you have to make sure that you're not trouncing the previous record, which I do all the time. How do you manage? Is that one of the records that you do manage, or
for text records?
Yes.
So we are able to do those, and I know it's actually a little, like, if you look at the APIs for the different clouds, like how they manage with the quotes is slightly different. So we do have. We do have that built in, and you're able to create text records just by simply going in and entering it here, and the system's smart enough to know I'm pushing this record to Azure. I need to quote it this way. I'm pushing to AWS. I quote it this way.
Audit trail, not Cloud Trail, but like, what do you do for auditing actions and?
Sure, absolutely, yeah. We and I won't go down there now but we do have like a full audit logs and system logs in the system, so I could go in there. Look at audit logs, and I could see those changes that I just pushed, and I could see them attributed to my username, that I pushed these records to AWS, I pushed these records to GCP, and I did it at this time.
On both sides of it, though, when you're in AWS, what if I make a change in AWS? Are you seeing the logs of the DNS entries in AWS and Infoblox?
So if you're making that change in AWS, we're not at this point ingesting those like CloudTrail logs. So you would have to track that audit change in AWS itself.
But would you have an audit record showing that it had been updated at least? Updated in AWS, and you sync in that change. Is your audit log going to say this record's been updated?
Yeah, it's going to be in a log. I apologize. I think it's actually in the like the system log and not the audit log, because it's a part of a discovery process versus a human interaction.
Okay. That's the point.
But it is going to be in there.
That did it if they're pulling in that change.
Yeah.
What do you have like granular RBAC that goes above and beyond what we have? And so you could give somebody, hey, you can access this zone and you can access these records in that zone.
Yep, absolutely. So we have this concept of access views, right? So I can take an administrator or a user, and I assign him to an access view, and then I assign that access view to various objects, right? Like I could assign it to this DNS view, or I could assign it to just the DNS zone. And then using a policy, I could attach different administrators to that access view and say, okay, this group of users are DNS administrators for access view 1, meaning that they can only see and interact with, say, this aws.mycorp.com zone, which is a part of that access view 1, and they're only allowed to do certain things to DNS, right? I could actually limit them down to that. So you have very, very granular levels of control, and we can do that across not just the DNS, but the IPAM side as well.
and a random thing that just, let's just say hypothetically, I ran into this the other day, where say you forget that you're 1 year from your last time you re-registered the domain, and say you forgot to auto renew, do you have things like to watch for, like life cycle of DNS records and when renewals are coming, stuff like that?
We're not doing anything right
Not at the
now.
registrar
tracking
level,
domain
but only down at the active
registrations.
registrar.
Yeah.
Okay.
Yep. So we're going to see the host, like say you're registered through AWS and you've got your hosted zone there in AWS. We're going to see the zone, but the zone doesn't necessarily reflect anything as to when that when your actual registration expires, right? And so we're not interacting with that piece of AWS yet.
And there's one AWS oddity in that when you register in AWS, it picks the 5 NS servers that it attaches to the record at that time, but they can change, and Route 53 does not change.
Mm-hmm.
Can you do things like spot the mismatch where the SOAs don't match what's in the active managed zone?
Yeah. So we would see that here, and as changes like knowing that these NS records are dynamic, so we're going to update those as well when we do those periodic syncs, right? So while we're able to push directly from here, we're still also doing a periodic sync on the back end to rectify. Okay, did AWS make any changes to something like those NS records that we don't necessarily control?
Nice.
Yep. All right. So the next thing I wanted to show, so we talked DNS management, right? So the next thing I wanted to look at is the IPAM management side. I'm skipping the DHCP because it's kind of boring for a demo, but we'll go right into IPAM, and I'm going to use kind of a use case that Glenn talked about, right? Where we have a customer and they're managing those different cloud environments, and they're doing so using like tag data, right? So we could have, for example, that those tags on environments for prod, for dev, for all our staging and other things like that, and then we could have blocks set out, tags for the different clouds and whatnot. So I'm doing a very simple implementation of that here. I've just created these 3 IP address blocks, and I've assigned them to the various clouds, right? And as a part of each of these, I've just given it each of them one simple tag with a tag that says cloud, with the value of the cloud that I want it to be used for. And just like the customer's doing, I'm going to actually make that implementation and tie those together using Terraform, right? So we can see right now my Azure space here, I don't have anything in, but I've got a new Azure account, and I need to stand up a landing space in there, right? I need a VNet, I need some subnets to it. I probably need a lot of other stuff to it, but I'm just going to do the basic pieces for this demo. So what I've done is just built a simple Terraform module, right? And all my Terraform module does here is it looks up that IP address block by that tag of cloud, right? So we're gonna look for that tag of cloud, and if it says AWS, we're gonna look at the AWS block. Azure, we're gonna look at the Azure block, etc. And then what we're gonna do is we're going to take that block, and we're going to create basically a new block nested in it that's going to become the IP space or the container for our VPC or VNet. So all I'm doing is giving it that overarching block. I'm going to tell it the size of space to create, and then I'm going to let our API do the rest of the work of figuring out what IP addresses to actually use. Once that's created, I'm going to do the same thing with creating some subnets underneath it. I'm going to use that, let our API do all the work of figuring that out. So one of the nice things I like to point out here is that there's not a single IP address in my code, right? And so I don't have to know any IP addresses. I don't have to mess with any of that to do this. I can do this all based on tags and attributes that are more human usable and make more sense to us, right? So I'm going to go ahead and run first my Azure one. So in my Azure example here, I'm calling my module. I'm telling it the cloud is Azure. I'm telling it that IP space. I'm giving it a size, which I've just translated on the back end. So a size large is going to give me like a /24 VNet. And then I'm going to create some subnets on it. So then what I'm going to do is pass basically the information returned to that, right? Like the CIDRs for my VNet, the CIDRs for my subnets. And I'm going to feed them directly into Azure's VNet module, right? Which is just available on the Terraform registry. It's out there for any and all of us to use for free. I didn't have to write any code for it myself. So let me go ahead and kick this job off. All right, so I'm just gonna start this auto approve. At the same time, I'll show you, I'm going to do the same thing in AWS because, like I said, what's cool about this is we do it for all clouds. We're kind of agnostic to where we're doing it, right? So AWS using my same module, and then I'm going to point it and use that AWS VPC module, again, right there out in the Terraform registry. No code I had to write myself for that. So I'm going to kick off that one as well. And let's go back and take a look where
You
our
don't have like a Terraform runner that you're running in your environment. This is us like either doing a direct Terraform or a Terraform cloud pointing at.
And we absolutely could do that. I'm just doing it, simply on my laptop for demo purposes. But yeah, absolutely. You could run this out of Terraform Cloud. You could kick off Terraform runs. I've seen it done out of, say, Jenkins or something like that as part of a CI/CD pipeline, right, where you have this integrated into that. Yep. So let's see. Looking back at Azure here, there we go. So we can see we've got our VNet chosen. It's given an IP space, and then it's selected basically 4 subnets underneath it, right? So really quick, I'm going to go over here to Azure. This is my new resource group I've created. Inside of that, I've created that VNet. I know that's super small there, but we can see our range is the same one that we've assigned from our source of truth in Infoblox. And let's zoom back out and take a quick look at our 4 subnets, again, using those CIDR blocks that we assigned by Infoblox. So this is kind of just a simple demonstration of that, that use case that Glenn was talking about.